The following complex number in Cartesian form. Let's take some question. Problems ln of -1 and ln of. So if you say -1, that is compare with r cos theta plus iota sin theta, that the value of this -1 is cos pi and sin pi, that is 0. So it's better to write instead of 1, that is e to the power iota pi, as we can say cos pi plus iota sin pi, that is -1. So as we know, that is -1, we can write e power iota pi, substitute the value. So let z equal to ln of, for instead of -1, what do you write? E power iota pi. Now log m to the power n rule, so that is iota pi. That is, this is a purely imaginary number, you can say. What about this one? Let this be z. Now as this is I, so ln of I to the power I, so that we say I ln of I. And here for this I, this one argand plane, then that is 0 comma iota, this one, this is angle pi by 2. So we can say cos pi by 2 plus iota sin pi by 2. Better you write e to the power iota pi by 2. So for I we can write e power iota pi by 2. And here once again we can say this is minus pi by 2 and ln of e. How comes iota pi by 2 comes downwards? Log m to the power n rule. So iota square, that is -1 pi by 2. And that is simply minus pi by 2. This z is purely a real number. This is purely a real number, while this is as purely imaginary number, imaginary number. In this session, we will discuss about geometry of the complex number. In a straight line, we will find numerous of equations, as like equation of a line in 2-point form. Joining this 2 point, one line can be created on a plane. So on a plane, if you join 2 points z1 and z2, and if you join this line, here you will get a straight line as like this. Let this point be P, this be B, this as A, this here origin. If you join this O with A, Z1, O with B, Z2, and O with P, that is Z. So by using triangle law, also you can find this equation of line AB. Okay. Z1. So we say OP equal to, that is OA plus AP, and OA can be written as Z1, this is Z, plus AP is parallel to AB, so we can use T, where T belongs to any real number, Z2 minus Z1. This is the first equation of a straight line, where T belongs to any real number. So this can be considered as SL1. Now SL2, go for SL2. Another equation of straight line can be also derived from the same line. As you know, T is here real number, T is here a real number. You can use this. So what the value of T from here? Equation 1. From equation 1, T can be written as Z minus Z1 upon Z2 minus Z1 is equal to T, as T belongs to real, So left side is a complex number and right side is a real number. So is it equal? So if right side is real, then this is a purely real number. Means, what do you say? Imaginary part of this z is 0. So this is such complex number whose imaginary part of this is 0. So imaginary part of z minus z1 upon z2 minus z1 is 0, you have to make. This much is also a way to write a straight line equation. If you explore this, then you will get the second straight line equation in determinant mode, determinant form also. How? Let's see. So you can say, if any complex number, if its part of z is 0, if of any complex number is 0, so we say, so z minus z1 upon z2 minus z1, this you have to note down, and make it in bar as z minus z1 upon z2 minus z1 bar. 1 upon z2 minus z1 is equal to bar z minus bar z1 upon bar z2 minus bar z1, right? Into bar z2 minus bar z1 is equal to z2 minus z1 into bar z minus bar z1. Now cross multiply this. So what we say here, z bar z2 minus z1 bar z2, and here plus z1 bar z and minus z1 bar z2 minus z1. In this all equation, then what do we call here? That is z z1 z2 and bar z1 bar z2 1 1 1 equal to 0. If you open this determinant, let z1 and z2 are the two fixed points. Let z1 and z2 are the two fixed points. That is A, and one of them is B. If you join these 2 points like this way here, and here one of the another point, any point, locus of point you can say, which is distance from these 2 fixed points are equal. This trace as a bisector of this line, or particular bisector also you can say. So the locus of this point P will be the straight line. So in this situation, let this be Z. If this is Z, so this distance between n to complex number, you have to write log this Z minus Z1 mod. So Z minus Z1 mod means, or you say AP equal to that is BP. So we say Z minus Z1 mod is equal to Z minus Z2 mod. This is also a question of this point B, Z1, and here another point consider, that is Z2. And consider, now we are interested to write down the equation of line segment, let this A point be Z1 and B point be Z2, and this P be any point Z on the line joining AB, right? It is anywhere, not necessary that it is at midpoint, anywhere, maybe mid also. So anyhow, this one AP plus PB equal to AB. Some can write. What do you write? What you can write? Simply that is AP plus PB equal to AB. Okay. So let me write AP plus PB equal to AB. Okay. So for AP and PB you can write safely. What is AP? That is Z minus Z1 mod plus Z minus Z2 mod is equal to Z2 minus Z1 mod. Okay. So look at this point. This is also a way to represent the complex number, straight line equation. And if you say check the argument between these two, this is pi. So in Argand plane, if we define circle, then it's look like this way. Let the center, which is the fixed point I stated in definition, that is on origin. Here this is fixed point, and this is a variable point P, and its locus is such that it is always fixed distance from fixed given point, which is the radius. Let here the radius is a stand for B. So if we consider B as the radius and fixed point here, we consider origin in first case. So the locus of point P is circle. If xy plane is Argand plane, then we consider P as any complex number, which is variable complex number. Now this is the first circle equation. Z minus Z0 mod equal to B. Actually, we have already learned that the distance between 2 points on Argand plane, how one can find this is Z minus Z0, means this is C, let center, and this is P. So CP distance is Z minus Z0 mod. Z minus Z0. Here Z0 is considered as origin, so Z0 is 0 complex number. So that we say mod Z, and CP, that is radius, is B. Or in other words, you can say Z minus 0 origin is the complex number, so mod Z equal to B. This is the equation of circle whose radius is B, and center is at origin. If we generalize this and shift circle somewhere else, like center be at any z0 point, like this one. If the circle center is z0 and radius is still same b, and this is the point p z variable, so we say z minus z0 equal to b. This is the equation of the circle, z minus z0 equal to b. This one. So if you say here parallel to x-axis, real axis, let the angle be theta here. So here what we say, if the argument of z minus z0 is theta, so we say here z minus z0 is equal to, what is this distance? This magnitude is b, so b e power iota theta. This is also equation of the circle, which we say in coordinate geometry as like parametric form. If you put it this, if you explore this, then you will find x comparable to, you can say analogous to x square plus y square plus 2gx plus 2fy, and this entire is plus c equal to 0. Later on we will show this. How this comes? Let's see. First equation, as we have considered that z minus z0 mod equal to b, which is the equation of circle. Equation number 1, we know what is the property of mod. We all know well that squaring both sides is squaring mod z0 whole square and minus c. Now substitute this value here. What we say here, b is equal to under root, and for this z0, this is w, so w mod whole square minus c. This is the radius of the circle, and this is the sorry, this upon z minus z2 mod equal to k. The locus of circle such that PA upon PB is equal to constant. So K shouldn't be equal to 1. PA, as I know, as we know, the distance between 2 points PA, that is PA can be written as mod of Z minus Z1, you can say, and that is PB, that is Z minus Z2 mod, right? Z minus Z2 mod, and this is equal to K. So Z minus Z1 mod is equal to K times of Z minus Z2 mod. This is the equation. Here we can show that K shouldn't be equal to 1. Let's see, squaring both sides, Z minus Z1 mod is equal to K square Z minus Z2 mod. Z minus Z2 mod. Now we'll make a flow over here. As you know, that is mod Z whole square, that is Z bar Z, we can write. Okay, so for Z we can say x plus iota y, Z1 equal to x1 plus iota y1, and here Z2 equal to x2 plus iota y2. Plug in this value here, we will get the result. It's okay, minus k square y1, here it will be y2 similarly, and plus k square minus y, right, and plus, that is k square x2 square plus y2 square minus x1 square plus y1 square under bracket, and that is upon k square minus 1 is equal to 0. Although from here there is two conditions, k square shouldn't be equal to 1. So from here there is two conditions, k shouldn't be equal to minus 1 and plus 1. But k shouldn't be equal to 1 minus 1. This extra unwanted things also come. While this is the fallacy that what we are squaring from here, as we are squaring over here, so we are getting some extra unwanted results also. So this is not considered, and this is considered from if you consider the previous equation.